Okay, Bismillahirrahmanirrahim. Let us go into the last question given in our workbook, page 269. Question number 4. How do we integrate this? Now we have a definite integral. Why don't you try them first? Let me give you 5 minutes, and afterward we will compare answer. Okay, so try of your own first. 5 minutes starts now. So let us compare work. So as we analyze the question, since that the numerator value or the degree of the numerator is higher than the degree of denominator, we know that this is improper fraction. So we cannot decompose just yet. We need to do the long division and get the remainder over divisor. Then when you get the proper fraction, then only we are to decompose. So first method, okay, the first mark goes to your long division as we are rewriting it back. So it is x over one of this variable, this divisor. So there is x there. So hence our fraction just now, okay, it becomes x plus 1 over x squared plus x minus 12. So for this part, this is now a proper fraction, and only for the proper fraction we can decompose. So in order to decompose, you need to factorize the denominator first, and this is a linear factor. So when we decompose it, numerator there will become a single constant. I call it a over x plus b. And for this portion also, this is linear, so it's a b over x minus 3. There's a mark there for the correct format. Okay, and then in order to get the a, we have to get an equation correct, like this one. How to get to that equation? We need to compare the numerator, so we combine these two fractions. Okay, so it becomes a of x minus 3 plus b of x plus 4 over x plus 4 times x minus 3. So hence, then only you can compare to your numerator value. Okay, there is a mark there for this line. So it has to be correct. And in order to solve for the a and b, we know that there are two methods. I'm going to show to you these two methods. You can just choose either one. Method 1 is by elimination. Method 2 is by comparing the coefficients. So just for the sake of discussion, let me show to you we compare work. If you are trying using elimination method, you are trying to eliminate either one of this. Again, it comes back to this equation. In order to eliminate a, it's good that you replace x as 3. So you replace x on the left is a constant. Over right side, when x is 3, we eliminate a and we got the b. Okay, so 7b. So hence we solve for the b. And then if you replace the x as a negative 4, we can eliminate the b. So on the right side, we get 1 equivalent to a minus 4 minus 3 there, so we can solve for the a. Okay, and hence this is your variable. Make sure that you replace back into this function whatever the a and b that you are assigning. Okay, a is attached. For my case, my a is attached to the x plus 4, and so the b there is attached with the x minus 3. Make sure it is correct. If we are using method 2, comparing coefficient, how you are supposed to again it comes back from this equation 1 that we got. Expand it first and then rearranging it, okay, such that you are comparing the coefficient of x. For example, here 1 meaning 0, x plus constant 1. So the x coefficients of x on the left is 0. So 0. So we get a plus b equivalent to 0. And then compare to the constant. This is a constant value equivalent to 1. And then you solve simultaneously, okay, by substitute, okay. From 1, for example, the b is negative a, and then substitute b there, okay. Replacing the b as negative a, and we solve the a. After you have got the a, then you can solve for the b. So either method, make sure that you show it, okay, and then put it back, okay, correctly. So hence, as we decompose just now, we get negative 1/7 of this. Then you can easily separate, okay, the integral. Okay, there's a a1 there for the correct decomposition, and here we have the x just now. Okay, then you are to integrate. Make sure that you show your method. Here the method that we use is a simple u substitution. With the variable u, replace the dx as du. Here I'm playing with a y. Let y be this part. So dy, we replace everything into the y. Make sure you show it for the method of your simple u substitution. Right, and then we integrate all. Okay, here we have a variable u and ln u and ln y. Okay, here I'm not replace the boundary just yet because this is the u and the y. I want to replace back this u and y there in terms of the x, because these are the boundaries of our x. So we replace back the u and the y in terms of the x. So you can carry 1 mark there for the correct answer as a general form. Alright, then only after this we are to replace the x with the upper boundary minus replacing the x as the lower boundary. So we compare for our definite integral. Okay, there is the answer just now. Since that we are given a boundary, so from this answer, replace your x with the upper boundary. Replace x as 2. Okay, and then minus, replace x as 0. And be very careful here. Ln negative is undefined. This is why you have to have an absolute value there. So ln here, we are reading it as ln 1. Over here, ln absolute negative 3, we have to read it as ln 3 for it to be defined. Ln 1, we know it is 0. So that will be the answer. But you can simplify it. Okay, so make sure that you simplify. So as we simplify, we are to use the properties of our log to combine it. Okay, so it is, if I'm taking plus in front, so we have negative ln 6 plus ln 4 minus ln 3. Okay, so it becomes ln division, the subtraction will become the denominator value. Okay, so as we simplify, we get 2 over 9, right? So either you leave it in this format, or if you decided to expand this further, it becomes ln 2 minus ln 9. Ln 9 can be simplified further, such that ln 9 is actually ln 3 square. The power 2 that can be put up front. So hence, either you leave it like this, or you leave it as an exact value of 2 plus ln 2 on 7, bring up the 2 ln 3 on 7. Okay, this is if the question asks for the exact value. If the question did not mention anything, no problem, you can use your calculator and give your answer as decimal number. Okay, let us count how many marks do this question carry. So to integrate this, we start with long division M1. Okay, until you can get into the quotient x plus remainder over divisor. Okay, As for this portion, we have to decompose it further. Make sure that you get the format correct until you can get one line equation M1. And from this line equation, you are to solve your method to get your constant A and B. Whatever method, okay, just choose one. After that, you are to replace back this proper fraction into separate variables there, okay, separate fractions, and put it back into your question. This portion we can separate now in terms of a simpler fractions, A1, and then you are to integrate term by term. Over here, show that you are using a simple u substitution. I'm playing with the variable u, and here I'm playing with the y. Make sure you get this, and then before you are ready to get to your answer of the integral. Okay, there's a M1 for the u substitution, and then you are to integrate, show that you have it in terms of a ln u and ln y, okay, A1, and replace your answer in terms of the x. Okay, so there might be one more mark for your answer in terms of your variable x before you replace your boundary. So this is definite integral. So replace your boundary now, yeah, in the boundary of x. Upper boundary, replace x as true, minus lower boundary, replace the x as 0. And then substitute and solve it, okay, accordingly, and simplify your answer. If the question asks for you to give an exact value number, you have to leave it as a single log function or something like this, simple log function, log 2 and log 3. Okay, so altogether just now we have 10 marks. Alright, so don't stop there. Make sure that you do more exercises. So thank you.